This
So we
conference
today
will now be recorded.
today we'll close about the heap dump, the heap part, and I'll tell you the heap dump, how the different ways to take heap from command prompt and other tools when I show you the real time. Like when I show you some hands-on exercising, I'll tell you how to take heap dumps and the different ways to take the heap dump. Okay, so before starting this, uh, yeah, again, the reason for I'm actually trying to help with as much as information, as much as I mean the total information that I have from all the different heap area. So basically, before you troubleshoot, before you identify anything with respect to the heap, the memory analysis using different memory analyzer tools to understand the heap, what exactly happened, you need to have the basics of memory, as I explained you before. And on a very high level, again, JVM, right? Memory in JVM, memory is divided into two big parts. The first one is stack, and the second one is heap. Okay. So let me share my screen. There is one document I have prepared for you. I'll share it after the class. If you can go through this document, you'll be able to understand all the different areas and what is heap, what are the different areas in heap, what is meta space, and what are all the different parameters that you have to set as part of heap. Okay. So we will talk about garbage collection going forward. Tomorrow class is all about the garbage collection, how to make the objects eligible for garbage collection. What is major, minor, and full GC? So where does that happen on each and every individual area in heap? And most importantly, we have four different algorithms, garbage collection algorithms. We will discuss in depth about mark, sweep, and compaction, CMS, serial GC, parallel GC, and G1 GC tomorrow. So in today's class, we will talk about heap. Okay. So basically, the heap. As I told you, memory is divided into two big parts. One is the stack and one is heap. Basic and the heap is a huge amount of memory compared to the stack. Basically, if you take heap and stack will be some 40% of the memory allocation, and the remaining heap you can give 60% of the memory location. And yeah, can anyone of you tell me what is stack memory? We already discussed, if you remember.
Stack is for threads.
Okay, basically, stack in Java is a section of memory which will contain methods, local variables, and other reference variables of all the objects. Okay, is always something like referenced from the objects. This is nothing but stack. Whereas heap memory, it will contain all the objects and also contain its reference variables, and also all the corresponding instance variables are also created in the heap. Okay, and coming to the memory allocation in Java, the JVM is divided into some four main memory areas. Okay, one is the heap. If you look at okay, this one is heap, one is stack, one is code, and one is static. You can understand this at a very high level. You need not go and understand all the different runtime constant pool, Java stack memory, and memory pool method area. You need not understand all this. From a performance testing point of view, we can discuss only uh, Java JVM memory locations into four categories. The first one is always heap. You will be working on this area for all the troubleshooting, for troubleshooting all the performance issues. And the stack, code, and static. Basically, the code memory area, right? This section will contain all your bytecode. Okay, whereas stack, as I told you just now, it contains all the main methods, local variables, and reference variables. And when I talk about heap will only have all the object related data with all its corresponding reference variables and instance variables. And static section, right? There are something like long lived objects which will be continuously accessed. and all the static data and methods will be stored in static section. Okay, and there are few points which every performance engineer has to remember, and he has to understand all these main points about the heap dump analysis. Every time when someone like the performance engineer at the very early stage, at the very early days when he started his career, most of us, like when we started performance testing, most of us, we did not know about Java heap or heap space in Java, right? Even I am not ever, until I get some 3 to 4 years of experience, what is heap, how do we define the heap. So I mean, what is the minimum and maximum heap that I have to define? There will be plenty of questions like, can the heap, the minimum and maximum heap can be same on the on the server that I'm working? Like what heap do I need to define if I'm working on a Unix server or a Linux server or a Windows server? So you have such questions, but to start something called heap, when we start doing this professional performance testing, monitoring all the servers or trying to understand what is happening in the infrastructure, especially the Tomcat, WebLogic, WebSphere, any application server that you take. So you will come across one of the most important error called java.lang. Out of memory error. Then once you see this error, this is the main culprit, and this is the only reason for every performance engineer to go back, and he will start working on heap dump analysis, the memory statistics. Okay, and there is one famous article for all the Java performance issues from Charlie Hunt. You can learn more about the Java performance with respect to all from a programmer side. You can learn all performance issues, profiling, and advanced tools. How to, I mean, there are some 10 to 15 different ways to take and analyze heap dump, which will identify all the problem areas. You can go through that link, but at a very high level, again, from a performance point of view, we are covering only the heap part for now. So again, when we talk about heap, when you write a Java program, or when any Java program is started on Java virtual machine, it gets some memory from the operating system. This is the first point. Got it? So when you write some program, you run it. When Java JVM tries to execute that, before it gets executed, it will get some memory from the operating system. Okay, and all the objects are, I mean, they allocate memory in something called heap. Okay, and all these objects in heap memory can be shared between all the threads. Okay, and the practical limit. So this is one of the most important question. If I ask you, on what basis do you set this heap size? Anyone? How do you decide the minimum and maximum heap size of your load test? I'm asking, the practical limit for Java heap size is typically what? For a conventional JVM, if you have too many garbage collection passes, again, we'll talk about garbage collection pass, but most of you have worked on so many applications, so many projects, right? How do you define this is my minimum and maximum heap limit? Anyone?
I think that depends upon the application. There is no exact, or we cannot say that it is a defined kind of thing.
You're right. And any other answers? Or I mean, it is like, we'll put the question straightforward. Like, what is the practical conventional heap size of a typical JVM? Most see, when I say it is a load testing application, when you are doing load testing on any application, it means that you are dealing with large heaps. Simple. Even if you test some 400 users or 100 users concurrency test, you need large heap for that. Many types of application will benefit only from very large heaps, like memory computing. If you work on any database replication testing or big data applications or analytics or any web personalization and any e-commerce or banking application, right, which are more frequently accessed continuously across geographical locations with high user base, you typically have uh, some larger heaps. So can you tell me what is a larger heap? Basically, some what from which GB to minimum and maximum that you give? Okay, again we'll talk about this one. Uh, Another question from the same area. So can you tell me, can I give 100% 100 GB as my heap? If I'm working on a big data application, I'm running a 5-day load test. Can I give 100 GB heap, maximum heap? Yes, no, anything is fine. If you say yes, I'll ask you why. I'll not ask you why, but again, I'll explain you. But I'm just trying to understand. Yeah.
100 GB may be too high,
Mm-hmm.
but maybe it will take a lot of time to fill and garbage collection to happen. It may take a lot of time.
Yes, that is one strong point. Yep. So, and another question, can we give the minimum and maximum heap size as same? Like minimum I give 4 GB, maximum I give 4 GB.
Yes, we can give.
Can you, so can anyone tell me what will happen when you give minimum and maximum heap size as same?
Heap size will not change even if the number of objects are increased.
Right, you can give same, but it will not show any negative impact on your performance. But whereas when I see when I asked you about the practical limit of for Java heap size of any conventional JVM is typically 2 to 8 GB. You can give minimum of 2 GB of minimum and 8 GB of maximum. Okay, and it always depends upon the type of application that you're testing, and there are something like memory footprints. Before there is something called object model designing from the development side. They will take care of how they can set the heap size. Okay, the minimum and maximum, and also you can also give there is something called physical memory. The heap memory should be 1/4 of your physical memory. If your physical memory is 1 GB, only 256 MB of heap can be given. This is a simple technique. If there is something called physical memory of any server of any memory structure of a server, so 1/4 of the physical memory you can give as heap. And I can also give 100 GB, but if I give 100 GB of heap, it will not crash the typical JVM, but it will periodically pass. It will continuously pass for minutes at a time, and this limits the application performance. Okay, someone told me just now, like if you have a continuous GC cycles, if a garbage collection is continuously happening, then there is something called past time. This is called past time. That means that this is the stop the world events will occur, and the application will literally hang for some time, and whatever the time the application is hanging, the same time will be added to your response time. Okay, and the GC pause time should not be greater than 500 milliseconds. If your GC pause time is greater than 500 milliseconds, that is a bottleneck. If you give larger heap sizes, it will have continuous the I mean the GC will kick in more frequently. It will run again and again, where it will halt the application, where it will hang the application literally to halt for a couple of minutes, and this will create a longer GC pause time. And if you have a longer GC pause time, the application will wait. It will be in stuck state, and it will stop responding. And if the GC pause time is 2 minutes, and if your response time of that heavy loaded weighted transaction is 2.5 seconds, and the GC pause time which halted the application for 2 minutes, this gets added to your response time of that particular transaction. Now it will impact the total performance, and it will give the response time plus the waited time of the GC, okay, which is 2 minutes. I mean 62.5, sorry, 122.5 seconds. So you cannot give a larger heap size. Even if you give the larger heap size, you need to understand the application working, the object model from the development side, and accordingly you have to give the JVM heap settings. But a typical JVM, it is always, you can, the maximum heap size of a 64 machine is 32 GB, not more than that. And you can also give more than 32 GB, but it again depends on the type of infrastructure that you're using. If you're using a very high configuration servers with respect to hardware and software, where you're focusing on a heavy load test with high user base, then you can give it. There is I mean there is no limitation as such that you have to give only 2 GB as minimum and 8 GB as maximum. And another question you can you can have, like what is the minimum and maximum heap size that I can give on Windows server or Linux server? Okay, when you compare Windows and Linux servers, right, the heap will be you can give the more heap on Linux servers when you compare it with Windows servers. Particularly, it is I mean, it is a general comparison of both the Linux and Windows servers. But when you give heap, right, you can give the default heap sizes on any of the flavor like Windows and Linux, but Linux you can give more heap when you compare it with Windows. And this JVM settings, right, it is they highly vary from JVM to JVM, and the operating system that you're using. The defaults, you cannot, please do not go with the default settings of your heap. Before you start your load test, don't go with the default heap settings. Go back, check your heap settings, uh, and then accordingly you can set your heap settings depending upon your application. Talk to your dev team, and then you give minimum and maximum heap size. Okay, for example, maximum heap size for a 32-bit Solaris operating system is 3670 KB something. Okay, and the maximum, like you can call it as 36 MB, and the maximum size, the minimum is 36 MB and the maximum is 64 MB. And for 62-bit machines, right, it is now increased to 30%. Whatever you give on 32-bit machines, you can always set some better values on 64-bit machines. And another way to find default heap size of JVM is to start an application with default heap sizes, and you can monitor with JConsole. So if the question is like, how do you know the minimum and maximum heap settings that you have given? So how do you know it? If you want to know the minimum and maximum heap settings, how do you know that? I told you, right, last time. You can simply open your JConsole, and there is something called VM summary tab. From that, you will be able to see all the minimum, maximum, and other default XMS and XMX values that you have given. You can, this is available from JDK 1.5 onwards. You can directly go to JConsole and you can see all the heap minimum, maximum, and how the heap is utilized. Okay, and every time before you start any load test, it is your responsibility to check with the dev team on how we can increase heap size based on your application needs, requirements. And I always recommend you to avoid using the default JVM heap values. That is not at all a best practice. Okay, and if your application is large and lots of objects are created, you can change size of heap by using JVM options like same XMX and XMS values, which are again saying the minimum and maximum. Got it? So
Okay, one question I have.
yes, please.
How about if that is a cloud-based like containers and microservice architecture case? I mean
That is
that.
what it has to be defined from any of the capacity engineer, like who takes care of, who works completely from the infrastructure, right? Like you need to get in touch with the AWS admin or Azure admin to understand how much of heap you have to give. You cannot decide that.
Okay, because what I observed is they have given the default minimum access 256 and 512 for each microservice.
But again, you have one strong point here. There is something called PermGen, okay? PermGen. You might be knowing about PermGen, one of the area in hotspot heap structure, right? So
Yes, yes.
I'll show you that one moment. So from Java 8, that has been replaced by something called Metaspace. Earlier, now what the performance improvement that they are seeing in Metaspace is, see, if you look at here, with there is with Java 8 there is no PermGen. Let me show you the diagram first. If you look at the here, there is something called PermGen. The first one is young generation, the second one is old generation, and the last one is permanent generation. Okay. Even if you remember last time, I have given you a wrong explanation on this. The minor GC will happen on young generation, the major GC will happen on old generation, and the full GC will happen on permanent generation. Okay, we'll talk about that in detail in the upcoming classes, in tomorrow's class. But when I talk about, for your question, when I talk about Metaspace, right? Earlier in PermGen, you used to see so many java.lang. Out of memory issues. Okay, but after something called Metaspace that came in from Java 8, so what it will happen is, even if you go with the default heap values, the main advantage of using Metaspace instead of PermGen from Java 8 is it will automatically increases the heap size. You got my point?
Yeah, yeah.
PermGen, we don't have that option. We don't have an option like automatically increasing the heap size. But whereas in the Metaspace from Java 8, what will happen here is it will the memory region grow. I mean, it will increase automatically by default. Okay. The main reason is the garbage collector will automatically trigger cleaning all the dead classes, which is not objects. It will directly create all the dead classes which are referenced. The entire complete class metadata when it reaches the maximum metaspace size. So the advantage of using this metaspace is the JVM has reduced 75 to 80% of throwing an error called out of memory error. There is no error called out of memory. It has been already avoided by JVM internal itself by something called Metaspace, and it is not avoided completely, 70 to 80%. So even if they take, if they are using something called Metaspace, and even if they take uh, Java 8 version by using some default values, so what it can do for them is it will automatically increase the heap size when required. So that will avoid giving us the out of memory issues. For that reason, people are also going, some people are going with the default values as well, only if they are using JDK Java 8 and above. Got it?
Yeah, yeah. Okay, thank you.
But again,
One more.
on-premise, a physical setup, having the infrastructure on the environment physically and putting it on a different cloud environment is always different. There will be a huge performance impact, some latency issues. You have to check thrice or twice with your dev team, if and you have to reconfirm if you can go ahead and do with the if you can go ahead and conduct performance testing with the default heap values. Please confirm that, and you can do that, because if you go with the heap values, you run a test for 2.5 hours, and immediately you got out of memory error, then you have to change your heap settings, which will waste your time and effort. So that's the reason you need to reconfirm with the dev team, and then you go ahead with the you can take a call on whether you can go with default heap values or you have to increase it. Okay.
Okay, thank you.
Yeah. So again, I told you, right, maximum heap size default for any server, as we know, any server, if you take any JVM, right, the default heap space can be 1 GB to 4 GB of any 32-bit JVM. Whereas if you take 64-bit JVM, I told you, right, it will be increased up to 30%. You can give some 1 GB to 8 GB or 4 GB to 16 GB or 32 GB depending on your application needs. For our application that I'm testing currently, I have given the maximum
RK,
heap size.
RK, I have a question.
Yes.
Where is this metaspace actually located?
I mean, I did not get your question actually.
See, I mean, before this Java 8, you said that it was permanent. It was permanent space, and it was
Perm,
located perm
Yeah.
generation. Sorry, yeah, perm
yeah.
generation, and it was part of a heap memory. So now it is called as metaspace. Please let me, I mean, understand. I mean, let me correct if. Please correct me if I'm wrong.
No
Metaspace,
issues.
as far as I remember, it is a place where the code will be loaded. The code and all will be stored. That is a space. That is metaspace, is what I understand. Is that correct?
Only one key difference between PermGen and Metaspace. Okay.
Mm-hmm.
PermGen is a part of Java heap. Okay. Maximum size
Mm-hmm.
for PermGen can be configured by XMX option. But when you take
Okay.
Metaspace from Java 8 is not the part of heap now. Now,
Okay.
rather,
Okay.
it is Metaspace is a part of native memory, which is also called process memory, which is again
Okay.
limited by the host operating system. And Metaspace will have all the static content, static data of all the long-lived objects.
Mm-hmm. Mm-hmm. Okay. Okay.
Okay.
So,
So will that be located in the RAM itself, or is that in some place else?
No, it is the
Metaspace part.
no, it is the it is there are there are different memory areas we are discussing, right? There are different
Mm-hmm.
memory areas
Correct.
in the heap in JVM. One among
Mm-hmm.
that JVM is heap. We are only talking about heap. There is also called method area, heap, PC register, stack area. There are lot of other different memory areas. So if you
Correct.
take
Perfect. I got it.
okay, if you
But
take
my question is like, where is the metaspace located?
okay.
it's a part of native memory now. It is not the
Native
heap.
memory. Okay. Okay.
Okay, it's also called
Okay. Okay.
process memory.
Okay.
Mm-hmm. Mm-hmm.
Okay. If I
Yes,
may,
sir.
if I may understand you, the meta, I mean the PAMGen is located in the heap.
Yes.
On the let me say on-prem application, and the metaspace is for cloud, you mean?
No, it is not that. It is not that. You are wrong. So this is same for any kind of environment that you have. It can be on-premise or cloud-based applications. It is same for everything, but
Okay.
it depends on what version of Java that you're using. If you are using below Java 8,
Okay.
so it is like the PermGen. So in place of PermGen, for Java 8 and above Java 8 versions, you will have something called Metaspace.
Okay.
Okay,
So it's just
so
a name change when you go to higher level, higher version of Java.
Right, and I told you the only key difference is PermGen is a part of heap and Metaspace is not a part of heap. It is a part of native memory and it is also called process memory. Okay, what the main advantage of Metaspace is, there is something called lifetime of classes and their lifetime of classes, right? There are few things which are continuously accessed, some class loaders. So as long as the class loader, all the class files or the methods or the objects that are continuously accessed on daily basis in the year continuously, until and unless the user stops accessing that, the class loader data containing all the corresponding information in the class loader, it will remain alive in the meta space and it cannot be freed.
Okay.
Got it?
Yeah.
So even the garbage collection will happen on this meta space and it will try to kill all the dead classes. Okay, it will remove the dead classes and free up the memory. But the main advantage of metaspace is it will store it, all the continuously accessed class loader files will remain alive in the metaspace and they will not be freed until the garbage collector kicks in. We will talk about garbage collector tomorrow. I don't want to talk about garbage collector today because I don't want to confuse you. Okay, you only focus about the Java heap today. Tomorrow I'll talk about garbage collection.
Okay.
Okay, even if you have questions on garbage collection, I'll clarify it tomorrow, only for the reason heap and garbage collection are completely related. But if you understand, if you get the once you get the complete understanding about heap, then you will understand garbage collection very easily.
Sure.
Okay, so I already told you how much memory you can set for 32-bit and 64-bit JVMs for Windows and Linux. And if you take Java heap and garbage collection, as we know, many of the objects are created inside the heap, and garbage collection is a process which removes all the dead objects from Java space. Okay, and it will return back the memory. Okay, so all the objects that are created, before the objects getting created, I would like to add one point here. So how frequently the objects are getting created, how many number of objects are typically created in 1 minute, or one functionality, one use case, how many multiple objects are created, what is the object creation rate. There is something called object creation rate. The developer will understand that point. So the developer will decide the object creation rate and the type of objects that are created, and accordingly we will give the minimum and maximum heap size. Okay, so for the sake of garbage collection, only for the sake of garbage collection, heap is divided into three main regions named as young generation, old generation, and perm generation. Perm generation is now called metaspace, and in the young generation you have Eden, S0 and S1. Okay, to define the young generation, I have already given the values. I have already shared it on the WhatsApp in the last class. So young generation hyphen XMN will give the total young generation limit. Okay, the total Java heap will define XMS and XMX values. Perm size hyphen XX perm size and max perm size will define the perm size. Okay, if you look at this diagram, the first one which I highlighted just now, the minor GC is happening on Eden, S0 and S1. This is not only on Eden. This minor GC will happen on Eden, S0 and S1. Okay, if you give 10 MB of memory allocation to young generation, and the survivor ratio if you give to 5 MB, 50% of the total young generation heap, which is 5 MB, will be part of Eden. The remaining 5 MB for S0 and S1 will be 2.5 MB and 2.5 MB each. Okay, so on the PermGen, the full GC will happen on PermGen. Okay, the difference between minor GC, major GC, and full GC is minor GC will happen on young generation, major GC will happen on older generation, and the full GC will happen on the perm generation. Basically, the major GC will take a very long time to clear all the objects. Okay, and when I talk about garbage collector is the process of deleting the unused, unreferenced objects which are no longer required. These are removed only to free up the memory, and it will free the memory for the next objects that are in pipeline, which has to be created and saved in heap. Okay, so this is all about heap. Now, when we the main culprit for heap analysis is out of memory. As I told you, JVM tries to run garbage collector to free any available space across all the different areas of heap, and it will make the memory available for the remaining objects. Okay, to resolve this out of memory error, you need to take a heap dump. You need to understand your application object profile. I told you, right? Object creation rate per second per minute. What kind of objects that you are creating, which objects are taking how much memory. So to know all these parameters, you need to use some profilers. I told you, right? JProfiler, JConsole, JVisual VM, AppPerfect Java Monitor. There are other command utilities like JHat, JStack, JMap. By using process IDs, you can take a heap shot, heap memory shot, snapshot, and you can analyze, troubleshoot this out of memory error in Java. And this is one interview question. What is the use of metaspace? When they ask you, metaspace has some kind of unique feature which will automatically increase the heap size. Even if you go for a load test with default heap values, it will not be a problem, because if it is automatically increasing the heap values depending upon the need, then the possibility of seeing the out of memory exception, java.lang.out of memory exception, is very rare and very less. Using metaspace will 70 to 80% will completely avoid this error. Okay, and by taking this Java heap dump of any Java heap memory at a particular period of time, you will understand all these things. You can troubleshoot all the different memory leaks in Java. You can troubleshoot out of memory. You can use various tools inside JDK. I told you, right? You can simply install Java. You can go to JDK. If you double click on JConsole or JVisual VM, it will directly open it for you with all the graphical representation of data with all the heap statistics. You can also use JMap command to get the Java heap dump, and this will create a heap dump file, and then you can use like jhat-java heap analysis tool with the process ID. It will capture the heap dump. Likewise, you have other utilities. I'll show you the different ways to take a heap dump when I show it to you on the tool on how to use it. And uh, there are few important points. Java heap memory is a part of memory allocated to JVM by operating system. Okay, but only thing that you're doing from your side is you're giving the numbers, that's all. Internally it is already defined as heap. The memory is allocated by operating system, and it is decided by the total available memory, the physical memory on the server that we have, depending upon the configurations that we get. Even no matter if you run it on cloud or if you run it on premise, uh, depending on what RAM you have, you decide the minimum and maximum. You just give the numbers, but you need to understand the application profile. Okay, you can increase or you can change the size of this heap space by using Java command line directly. You can give xmx 1064m, and if you give the program name in the command prompt, it will directly set the minimum and maximum heap size of that particular program that you want to execute from Eclipse.IDE, Eclipse IDE. Okay, and you can also use JConsole to get all the max memory, total memory, free memory. I have written a program, if you remember in the last class, I shared that program on the WhatsApp as well. Okay, Java heap space is completely different than stack. Okay, and Java garbage collector is responsible for all the reclaiming memory from dead objects, and it will free up the memory. Okay, every time you see something called out of memory error, you need not get panic. You need not do all the trouble. You need not apply all the troubleshooting mechanisms. Sometimes 50% of the 50% of the times you can solve this out of memory exception by just increasing the heap. Okay, if once you get out of memory error, don't do all the investigation, and you need not do all the postmortem techniques. Instead, you can just give the max. You can change the maximum heap size from 4 GB to 8 GB. Will solve the issue. That's all. The first thing that you have to do is increase the heap size. Okay, we already discussed a few questions like what is the maximum heap size for a 32, for a 64-bit machine, 64-bit machines. Can I change my heap settings during the load test? This is one question. Anyone? The load test is happening. Can I change my heap settings when the load test is happening?
I guess yes.
Can you tell me why and how?
During the test execution, I mean, you can just use these tools. That's what I remembered. To be honest, I exactly I didn't remember, but you can use those tools and dynamically you can change it on the fly.
You can
I
change it.
think we can change, but it may not be effective immediately. We may have to restart, I guess.
That's
They
the
restart
problem. Actually, you're right. So you can do it, but it will show a very bad performance impact on your load test. You cannot do that because to reflect that changes, you need to restart your JVM. Okay, it is always the best practice. Before you have to give the heap values before you start your load test, before the JVM starts. Okay, and if you talk about the maximum heap size, can you place your call on mute, everyone? I'm hearing a lot of disturbance. All right, so the maximum heap size for any 32-bit or 64-bit JVM, you can give always 4 GB to 16 GB. That, I mean, if you have sufficient configuration for any load testing practice, the basic is 4 GB to 16 GB default, because you will be testing with so many transactions, so many requests, and so many users continuously accessed, right? So you can always give 4 GB to 16 GB, and I always recommend, if it is an endurance test, you can go with 32 GB as well. Okay, so now I have a question. When can I have a larger heap and when can I have a smaller heap?
Depends on the GC policies, I guess. I mean,
Okay,
whether you are taking a serial or parallel, or what is the pause times application
okay.
is with respect to the, you are concerned about the volume or with respect to the response times. Let's say it's a
You're
response.
you
Choose
you
one.
you you you're right. So when I give a smaller heap size, what will happen is the garbage collection will happen more frequently. Okay, but the GC pass is shorter, but if the garbage collection is more happening more frequently, that will impact the performance. Okay, and very soon it may lead to out of memory errors. So that is one disadvantage of giving a shorter, smaller Java heap, memory heap. And even if you give a very small amount of heap, it will hold only, the chances of holding the objects for a long time is very less. Okay, and it will it will fill every individual area in its hotspot Java heap structure very quickly, and it will occupy the memory very fast. It will hold only very few objects, and it will very soon you will see out of memory errors if the GC policy is not working efficiently. Again, if the GC algorithm that you're using, if it is not working efficiently, if it is not able to remove the unreferenced objects, the dead objects which are not alive, and still struggling to fight to free up the memory, you will see so many issues for small amount of heap. But whereas in large amount of heap, it will allow more objects to be created, and it will take some time to fill. All the areas will take some time to fill, and it will take some time to run the garbage collection as well. It will allow the application to run longer time between the garbage cycles that we can have. And the last important point, I don't know how many of you know this point. Okay, so there is one point called types of references. Okay, so these are basically the values that we have. You can take a screenshot. I have already forwarded you this one. In Java programming language, right, we have different types of references. Let me open this document for you. So do you see here? So depending upon the reference types, the garbage collection will be able to create, will be able to delete all the unused objects. There are different types of references. You need not get the complete understanding like a Java full stack developer, but this can be your interview question. Like if I ask you, how can you make your garbage collector to work more efficiently? It is when you get that question, you can say like the developer has to create the references in a way that he has to define which reference is what. He has to decide which object is what. Is it a strong reference, or is it a weak reference, or is it a soft reference, or a phantom reference? Okay, basically these are the type of references that we have. So depending upon what type of reference that it is using by that object, in the heap, uh, the garbage collector will decide the object eligibility, whether it can delete that particular object with that reference type, or it can still keep that in the respective area of that heap. So garbage collection has to understand which object is using what reference type. So that can happen only from the application design team and the Java development team. Before they write this code or before they develop this program, they have to write every object in a way that it is using a particular reference. Okay, for example, if you take strong reference, right, strong reference will not be deleted by a garbage collector at all. The object on the heap, it will not be garbage collected because it is a stronger reference. It is referring other objects, it means that it have too much of other strong dependencies of that particular object, and garbage collector at any cost, it will not remove the strong reference. Strong reference will be there in all the areas of heap. Even if it gets promoted after multiple cycles of minor GCs also, it will be still there. Okay, whereas a weak reference, right, weak reference can be easily garbage collected. Even if it is survived the first minor GC cycle, second minor GC cycle, third minor GC cycle, in the fourth minor GC cycle, it will be deleted as an unused object and it will reclaim the memory. For example, if you take any use case for a weak reference, right, is like a catching scenario. you retrieve some data and you don't want to store that data in the memory, and the same data can be requested again from one user or a different user, and again you are not sure when that data will be accessed or when it will be, where it will be stored. In such case, you will keep that as a weak reference, like low prioritized functionalities or low prioritized accessed feature in an application will be mentioned as a weak reference.
Excuse me.
In that case, yes.
What happens when a strong reference, if the developer made it eligible for GC collection, like dereference?
I'll tell you that tomorrow, because developer can make any object to be eligible for GC. There are four main different ways for making an object eligible for GC. Okay, there is something called nullifying the objects, or reassigning the objects to the existing objects. We have some different cases. I'll tell you that tomorrow. But only the developer can decide which object can be eligible to be garbage collected, and most probably most of the times strong references will not be garbage collected 99.99%, because they will be used somewhere else. Each thread will be using the same object again and again. Okay, hello.
Yeah. So 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 that said, strong reference variables, so they will not make it eligible for GC, right? That's it.
No, it is not that. See, if an object is even if it is a strong reference, if the object is continuously consuming memory and if it is occupying the memory, it will create a memory leak, right? In such case, either you need to optimize tune that particular object, or you need to make that object eligible for GC. So for example, if you think that object is no longer required, you will assign null to all the reference variables. When you assign null to all the reference variables, that reference of that particular object will disconnect. Okay, but you will not make any strong reference null, because when we call it as a strong reference, it means that it is accessed by many threads and it cannot be garbage collected. If you make that object to be garbage collected, the chances of failing that particular transaction will be very high, and you will see a very high error rate.
Got it. But when you say the weak, but still the developer needs to dereference, or it will be taken care by the GC.
No, he will not dereference it. But what he can do is, there are few scenarios. For example, I told you, right, there is a catching scenario. Catching scenario, what will happen is, 1 minute, I'm getting a call. Okay, catching scenario, what will happen is, a user want to get some data, and he don't want to store that data in the memory, and and even you are not sure whether the same data will be requested again by the user or not. So in such cases, when the user is not sure about how the data is accessed, if it is not stored, or if he's not sure about it can be accessed again, or it can be accessed from different user, when he is not sure about all these things, for such objects he will mark it as weak. So for example, if there is an object that is created, and if that is not in use till tomorrow evening, the objects get deleted. It will be collected by garbage collection. If someone is accessing it tomorrow, the object is again created in the heap. But what the developer will do for that is, he will mark it as a weak reference. When he mark it as a weak reference, even if it is marked as a weak reference, if the users are continuously accessing there are possibilities of getting survived from many garbage cycles. But if no one is one user is accessing that object in a day, the garbage collection cycles will happen and it will get deleted, the memory will be freed and it will reclaim the memory. So for most of the objects, when you, the advantage of keeping weak reference is it can be deleted at any point of time, it will free up the memory, but when it is requested again, the objects comes in again. Okay,
Perfect. So basically, it is avoiding some work of on the developer side, isn't it? I mean, you don't need to dereference those weak objects. Just as soon as he mentions weak, then at one point it's going to be deleted.
Yeah, it's very simple. If I have 3 types of testings that I have to conduct, I have to run a 4-hour load test, I have to run 400 users concurrency test, and I have to run a pilot run which will run for 15 minutes, which is of very low priority. I don't want to run it today. I will not run it tomorrow. I will not run it this week. So when you feel, when a developer feels that there are few objects like that which are of very low priority, he will mark it as a weak reference. It will not be in pipeline, and it will be immediately garbage collected, and it will have some space for other objects that gets created in the pipeline. Okay. So coming to the soft reference are more memory sensitive scenarios actually. This soft reference, right, this will be deleted only when your application is running out of heap memory. It's a direct saying. Okay, the soft reference, if JVM is identified that your application is running out of memory, then all the soft references will be deleted and the memory is freed. Got it? So when it is alerting out of memory error, it will create all the soft references first. Even after deleting all the soft reference to objects, but still it will not stop. You will see the out of memory error for sure, because there are some objects which are always a troublemakers for garbage collection policies. They cannot get deleted. Even any type of garbage collection mechanism you use, they don't get garbage collected. In such cases, the developer will step in. He will identify the objects. He will make that objects to be eligible for GC, and there are different ways. We'll talk only about garbage collection tomorrow. I'll explain you all that ways. Okay, and the last one is Phantom reference. Phantom reference, I'm not completely sure about what is Phantom reference, but I know what is, there is something called Phantom reference, and I'm not really sure. Even I don't know what is this Phantom reference. Okay, this is the latest reference that came in, but I'm not sure. And what I know from Phantom reference is majority of the references are not marked as Phantom. Okay, if you want to, most of the times these are used for objects which are no longer alive. I mean, in one go it will clear. If you want to clean up the complete memory, right, in one shot, you can mark all the references to, if you want to, if you mark all the references to Phantom references, 70 to 80% of the memory will get freed. That is what I know from Phantom reference. Okay, if you mark all the objects as Phantom reference, when the garbage collection happens, 75% of the memory is freed up. Okay, so this is all about heap dump, heap memory. The most commonly seen issue from the heap is out of memory issues that happens due to insufficient heap. Okay, this basically happens when JVM runs out of heap and GC is unable to reclaim the memory to meet the demand of the application. This means that the heap is completely filled with all the objects used, referenced and unreferenced objects, but they are not getting deleted. Now, the point for out of memory is, how do we identify out of memory? I'll not take, I have to take another 10 minutes. I'll close the call after 10 minutes. Now tell me, how do you identify the out of memory? Assume if I'm asking this question in an interview, you say that you have seen out of memory issues. You said that you increased your heap due to insufficient heap. Now tell me, how do you identify out of memory? Very basic question.
But I mean, you get that error. That is one thing, but that is at the end. But you will be continuously monitoring the heap, right? So you can able to see the pattern and see, yeah, we are reaching, something in a different direction. I mean, when the heap is continuously increasing, and your sawtooth pattern will be, it's going to almost a straight line. Then that way we can assume that okay, it's going something wrong. I mean, it could be out of memory or something. But by looking at the objects also, how it's being collected, and if they are accumulating or something, so we can say that we might reach at some point out of memory.
Yeah, perfect. You can identify this issue with any of the tool, JConsole, JVisual VM, JProfiler, JProbe, your kit profiler, app perfect profiler. If you use any profiler or if you use any APM tool, by looking at the metrics, most probably you see a sudden spike in memory utilization. That is nothing but out of memory exception. Like you see the gradual increase in heap, that is out of memory exception. You look at the graph and you see the heap and you see the utilization from the graphical representation and you decide this is an out of memory. Now how do you fix it?
I mean, you can increase the memory, but heap. But the thing is, we need to make sure, is it something with the memory leaks, or it is because of we still need more memory to run our application. Those are the things we need to decide before.
I agree to one point. Increasing the heap size for a heavy weighted transaction is sufficient. Sometimes even that is not sufficient, right?
Right.
So what is your other step?
So another point is like the proper GC is not happening, maybe because of that.
Perfect.
The objects are getting accumulated and heap is increasing and out of memory we are getting.
Right. Anything else? No, I'm asking how to fix it. You identified it. It can be because of multiple symptoms and multiple issues from multiple directions. But now you are increasing the heap size. I say that it is not sufficient. Now what is your next step?
Sometimes the
Should
code also may not be written properly. That also could be causing that kind of out of memory issue, like the design patterns.
Right. The code needs to be revisited to see why the demand is high in the first place. Okay. The code has to be rechecked. Maybe you are trying to pull millions of records from the database, or you are trying to process all of them in one go. And if you want to process something unnecessarily or simultaneously, the first thing that you need to do is you need to take help from the development team to identify why it is happening. I told you, right, there is something called object modeling pattern. There are some designs that they implement before they write this application, when they code or when they develop something. So the first, after increasing the heap, you need to ask your developer to check, to revisit the entire code. And if there are no proper code reviews after for every release, you will see all these issues every time in every release. That is why the reason code reviews is now a practice in every performance engineering assignment. Okay. And the second point main is heap dump analysis.
Sorry,
Yeah.
Eric, I did not get that. I got the point that it is maybe the application code is not proper, but how do we identify that
You
issue?
can't. No. You can't identify until and unless you have some hands-on core Java development, not core Java, full stack Java experience. You will not understand that. Even if your developer is trying to explain to all the performance engineers, you will not be able to understand it until unless you have some 2 to 3 years of full stack Java experience.
So how do we get that experience? Like,
No, only thing is you need to learn Java. You need to start coding. If you need
coding.
you need to start working. You need to start working with you need to have some development experience, and you need to participate in all the code reviews meetings.
Okay. Uh-huh.
Do you work for a product based company?
No, work for a servicing based
Okay.
company.
If any one of you are working for a product based company, you can directly request your dev teams to involve you in the code review meetings. Okay. Even if
Okay.
you don't get some experience, or if you don't have any hands-on experience, at least you can try to understand what they are talking, what improvements they are doing. Got it?
Okay. Okay.
Okay. It takes
So
years again.
okay. So what I understand from that application, what we can get is, like maybe because of the application issue, the amount of I mean, the heap memory allocation in the heap might be abnormal. Uh, Maybe that may be the symptom of application code issue. Correct me if I'm wrong.
No,
So
no.
I feel
See,
that is one of the symptoms.
application code issues are 80%, because the problem is you continuously test. You will conduct multiple rounds of performance testing. You see the same numbers again and again. If your customer don't wants anyone to touch from the code side, if the application is developed in the early 90s, 98 or 2000, if if your customer is not willing any of the engineer to touch his code, we cannot do any performance improvements on that. There are few migrations, there are few emerging technologies of 2020, 2015. There is something called orchestration. Everyone switched to monolithic architecture to microservices based architecture only to improve the performance. And you see majority of the issues are only because of inefficient code. Even if you look at majority of the job descriptions nowadays, they are calling SDET. We'll put SDET aside for now. We are not talking about any automation testing here. Eh, in the next 1 year from today, you can take the next 1 year. Hands-on Java experience will be a part of every JD. No matter you work for TCS or CTS, level 3, level 4 company, Java will be a mandatory skill for every performance testing job role. I'm not talking about engineering.
We lost you, okay.
We lost you, man.
Yeah, we are not able to hear RK.
Yeah. Network issues. Oh, man.
Hello?
Yes, sir.
Sorry, I told you,
Yeah,
right?
RK.
Actually, I have some issue with this GoTo. Actually, I don't know. It got disconnected all of a sudden. Again, I connected from mobile. So, am I audible?
Yes.
Yes, now.
One moment, please. I'm connecting my. So, what I mean to say is, so uh, every job role will include something called development experience in the next 6 months. I already started seeing that since last 1 year and 1.5 years. If you take ServiceNow, McAfee, Visa, Mastercard, and if you take any of the product-based companies, if you take Adobe, CA Technologies, all these companies will add Java as one of the main skill set. So I would strongly recommend every performance tester and engineer to learn Java. At least core Java would be more than sufficient to understand the code inefficiencies, to understand why how the application is behaving or what abnormalities you have. You can go
go for all these things. Okay. And another strong point is you will not, even if you have some code inefficiencies, you will not be able to understand what issues you have from the coding side. You need to definitely take the help from your one of your development architect to understand why it happened. Okay. Everyone is able to hear, right?
Yes.
Yeah, RK, we are able to hear. And RK, like, how do we start? We see, we are from testing side. We can join for any course for learning Java, core Java, but just by learning that, will that be sufficient, or is that expected? The hands-on experience is expected.
Now, for example, we have recently taken some 50 interviews, okay, for a senior performance engineer. Even 14 years, 15 years experienced candidate in product-based companies is a senior performance engineer, no matter what designation you have in your previous company. But when we evaluate, when I evaluate, I'll not. We have Java hands-on experience for 1 year. The reason why we expect people to have that requirement is he should be able to understand at least when he is using profiling tool, right? He should know how to read the thread dump file. If a thread is blocked, he should know why it is blocked. There are some Java mechanisms you need to understand. We started taking interviews from Java side. We very minimal level, but still none of them know like a simple program. If you are working on 20 programs from HackerRank, we will give, every company is now giving only basic programs. I will ask to write Fibonacci series. I'll ask them to write. Last time from the last 10 interviews, I am asking only to add 2 numbers, multiply 2 numbers. What is array? What is integer? What is an object? What is class? What is package? Nothing. No one is answering. So we did not. The requirement is still on hold. We have 7 requirements. We did not take anyone. The only reason is because we are getting people 15 to 20 years experience, but no one knows Java. Basics. Okay. So that is a different story. So what I'm trying to tell here is you will have 70 to 80% of the issues from the code inefficiencies. But if you want to understand that, if you want to become a very good performance engineer, you need to learn Java. Don't go with complete Java. Go with core Java. There is a instructor called Durga sir, that is Durga Soft. You will get all the 199 bundle in YouTube. Core Java by Durga sir, if you type, you will get that bundle. If you spend some good amount of time, you will learn everything.
Okay.
What is the name?
Okay.
What is the name?
It is also free, RK. That
This is
bundle.
free. This is free.
What is the name? The name of the guy?
Durga Soft.
I'll share you that link, and let me share you. I have one course with me for Java for beginners, some video course. I'll share it with you on Drive. Okay.
No problem. Thanks.
Okay. So
Yeah. Thank you.
yeah. Now okay. The another point is let us complete this first. We already got late. So there is something called a poor application response times, right? Poor application response times can happen because of what? I told you, right, about garbage collection pause, if you remember.
Right.
So if you see high response times or poor application response times, that will happen only because of garbage collection pauses. If you have larger heap, if you have too many objects that are created, continuously referenced, so when the garbage collection is happening, the application will literally halt, which is called GC pause time. All the threads will halt, and that pause time, which is less than 500 milliseconds or greater than 500 milliseconds, greater than 500 milliseconds is the value for GC pause time. this gets added to the response time. If the GC pause time is longer, if it is for 2 minutes or 3 minutes, these 3 minutes will add to the response time of that particular weighted transaction, and this will result in high response time. Okay, this can be, most of the time this can be resource intensive, which can cause high CPU, okay, high CPU spending, and it can completely bring the JVM down. So in such cases, you have to identify and fix that thing. The first one is out of memory. We already discussed about that. The second case is poor application response time because of garbage collection process. So to identify that, you have GC time graph. Okay, you can you will understand whether you have poor response times or high response times or very good response times. Basically this type of error, right, you get it from the real-time users, especially from the users who are working in real time. They say that, boss, when I'm trying this, when I'm working on this search ticket, it is taking high response time. At what time and when, which location, which browser, with what configuration, which URL did you use, what is the endpoint? These are all the areas that I take from my customer. And what I do is I go back and I look for my generational heap that is configured. With the heap, I'll also check the young, older and permgen, and I'll completely see how the objects are allocated, how the garbage collection is happening, which garbage collection is set, and again, this show can also be because of something like code related issue. So you need to analyze the code in parallel to tune the heap. Okay, so some JVMs like IBM and other from other vendors have an option to specify a GC policy, such as, I forgot that name. You can opt for GC pause, and you also have a threshold, okay, which can optimize the GC for a smaller pause time. There is option called OPT GC pause from an IBM JVM. If you set that option right, it will optimize the GC for a very smaller pause time. It will avoid the longer pauses, which will improve the application performance. Okay, and the last option is the memory leak. Again, the memory leak you can easily identify by looking at the heap graph. Okay, so memory leak is only because of the coding issue. You have to directly talk to the developer saying that I am seeing a memory leak. Okay, this can also happen because of the library files that you are using outside your code. There are some native codes which are written in other languages from the native libraries. You can also see these memory leaks from the native libraries and other libraries that are being used from that are using outside of your application. So to fix the memory application, there is only one way. You need to use the profiling tools to scan your application like JProbe. JProbe will directly identify the memory leak, and it can tell you what are all other areas that can be tuned and fixed. Okay, so these are the only issues for the reason that we take heap dump. Okay, heap dump can be invaluable tool for troubleshooting all the memory related issues. Like you can use any memory profiling tools. You can take multiple heap dumps. You can take a snapshot of the entire heap or a particular period of time, and you can identify all the objects that are filling up in the memory by analyzing something called heap dump. And the best tool for analyzing the heap dump, you have a built-in tool called MAT, Memory Analyzer Tool from Java. If you are using this one, it being used. Okay, this is the final conclusion. This is all about heap. Now I have only one topic that is left from heap is what are all the multiple ways of taking a heap dump. Then we'll talk about garbage collection tomorrow. All right.
One thing, we can discuss tomorrow. Maybe I can remind you. The question comes is usually either our physical memory or the JVM's heap, and also the CPU. What kind of standards that we need to recommend as a performance engineer, like 60%, 70%? What is the max? A ballpark.
No. Honestly speaking, customer wants us to give everything. He wants us to recommend all of the different parameters that everyone can set for a better performance. But in the real case, it will not happen. Even if you go back and tell that boss, use this heap values or use this GC policy. So they say that developers always work at their convenience. Okay, they'll not work for application performance. This is a fact. Go back and tell them that you have to revisit the code. He will directly tell you that we had 8 to 9 reviews till date in this sprint, which is only for 2 weeks or 4 weeks. They will conduct 9 to 10 code reviews. They'll tell you that this is what happened, but performance engineer will not be able to understand what improved with what. Now your immediate question would be, after having multiple code reviews, what is your final take on it? How can you say the application performance has been improved from 0.2 seconds to 0.01 second or 0.09 second? They cannot tell that. Even if you go back and if you give some strong recommendation, set this heap, give the minimum heap 4 GB, maximum heap 32 GB, run your test. They can't do that. They'll tell that our objects will definitely give you a trouble. That is what they are going to tell. And if they want to tune any of the specific main object, they have to change the entire object profile in some of the cases. For that reason, to avoid rework, to save time, developers will not agree with whatever the performance engineer is saying. That is one of the important issue. For that reason, the chances of improving the performance are very, very less, because the customer is not an SME. He is not multi-skilled. He don't know Java. He don't know performance testing. If some architect is saying that we cannot do this, that is a break-even point. They cannot go ahead and they cannot do any changes on top of it. So when you want to give any kind of recommendations or suggestions, you need to have strong Java experience, first point. Even if you don't have Java experience, but you can clearly explain to your customer, if you don't go with these values, if you don't use these values, you will not see the improvements in performance. Then client will take a call on it. It is not the developer who has to accept, but you should be very clear before you give such statements and recommendations to the customer. You need to know all the different areas from multiple directions. Are we doing correct? Are we right? So if you clarify all these things, then you can go ahead and do whatever you want, like for better performance. If you are a performance architect, again, even if you're a performance engineer with 2 years experience, if you tell that the garbage collection mechanism is not working as expected, I'm seeing high GC process, high response times, too many out of memory issues, the the memory is getting frequently filled, the application is going down, the application is very slow. For all these issues, you have to increase the heap, you have to profile, and depending upon that, on the test environment, you can do everything that you want. But only the problem comes only when you ask the developer to revisit the code. That is the only problem. Okay. And for defining all these values, again, there is an application design patterns, architecture design, so many parameters are considered. All right. So anyway, I'll clarify your doubt tomorrow.
Yep.
Again, from a performance perspective.
I still have a few more, but we'll talk tomorrow. It's too late for you already.
Right. So do you think this class is recorded now? Because it got disconnected all of a sudden.
No,
I don't think.
I see still recording. I can see that. I can see that.
Just give me one moment, because I'll connect again and then I'll disconnect. Okay.
Yeah.
I'll connect my laptop and I'll stop my recording. So any other questions you guys, if you guys have, you can always contact me. Okay. You can always ping me on my WhatsApp. Am I audible? Yes. Being the recording feature. The recording is still in progress, right?
Yep.
You can make one of you as presenter or organizer. Can you can you stop your recording? I'm not seeing this option here on my laptop.
Sure. Sri, SREE.
Yeah. I made you as an organizer. Can you stop the recording now?
I see. Yes, even at my end also, I see leave the meeting. I didn't see the stop the meeting. I think the leave the meeting also. I
All right. Just speak with Anita ma'am and I'll give you an update. Okay. Thank you. Thanks all of you for joining. Thanks for your time.
Yeah, I think you have recorded from the iPad.
You're saying something?
Yeah, I said that you are using iPad for the option.
No. I connected to my laptop again.
Yeah, but you started recording from iPad, right? Is that the case?
No. I started recording only from laptop itself.
Okay.
Okay, let us see after disconnecting the call.
Yeah.
Okay.
Yeah. Thank you.